All right, good morning, everyone. I couldn't quite hear you. I just want to make sure everybody's awake. Okay, one more time. Good morning. There you go, much better. If you're out enjoying the break early, come back in. You're going to miss a great presentation. Let's see. I'll get oriented. I'm used to a lapel mic, so I got to get oriented to everything. All right, so we're going to talk a little bit about networks of the future today. I'm going to try and stick to 20 minutes. I got a lot to cover, but be forewarned, I do follow the Guy Kawasaki rules for presenting. 10 slides, 20 minutes, and the font is always larger than 30 point. So you should always be able to see, hear, and understand and not fall asleep while I'm presenting unless you had a few too many adult beverages last night, but that's okay. A little bit about me. Blog address, blog.theitrebel.com. You can follow me on Twitter at @TheITRebel, or on most Slack channels, including Wi-Fi Pros, you can find me at @TheITRebel. Try to stick to that. I think my picture up there looks a little bit better than the real-life version of me, but anyway, we'll kind of keep moving forward. There you see the bottles of great wine, probably retail somewhere in the couple $100,000 range to the right person. But you can also see, like I said, you don't just simply set a network of the future on the shelf and let it contain dust and just kind of hang out there for a while. Moving on. Okay, so I've got 4 kind of general rules of thumb for what I consider to be a network of the future. Number 1, that network has to be flexible. Okay, we'll kind of talk about each of these bullets, so we'll just kind of move through these quickly. Number 2, has to be cost efficient. We have to make something that's affordable for businesses and enterprises and all customers really to be able to utilize effectively. Number 3, it has to have great ease of administration. It's not something that we want to sit there and spend hours and hours and hours configuring RRM or ARM or AirMatch or whatever variant your vendor calls it. However, Devin, this is not saying that I'm a firm believer in static channels. I think they have their time, but that's a whole other topic for another discussion. And number 4, they have to be intelligent. So what do I mean by flexibility in a network of the future? All right, so static networks are easy to design, easy for a professional that's done this for a while to design, and configure, right? So we've all probably had the time in our lives where we've designed a network with static channels. We print out our floor plan, we have all of our APs placed, or we're doing this in Ekahau. We assign our static channels, make sure our power levels are correct for the setting that we're, for the devices that we're trying to cover, and we move forward with the configuration and put it into operation, and fingers crossed, once we turn it up, everything's working well, and we don't have to make too many changes to it. However, a network of the future is one that exists not only in a static environment, but in a dynamic environment. Dynamic environments these days, in my opinion, are something that constantly evolves and changes, like this conference room, for instance. The network is always changing. Today, we're here, many of us wireless experts, we have multiple devices. Tomorrow, they may have a dance in here, a prom for a high school, something of that nature. So the network is always evolving and having to take into consideration what the purpose of the coverage and the performance of that network has to be for that particular given moment in time. They require, speaking of LPV spaces and dynamic networks, they require a lot of time to design and configure properly. We just had Chuck up earlier talking to us. I know he was heavily involved in deploying Levi Stadium for the 49ers. Many of you have probably seen and read a lot about that over the years. That was not something that we had a floor plan come across a desk at 4 o'clock one afternoon and said, okay, we need a complete BOM and a full design plan and a rollout deployment strategy for this by the time you get to work tomorrow morning, right? It was something that took a lot of time, a lot of care and feeding, a lot of advanced planning with multiple parties involved and multiple stakeholders to determine what the requirements and how the network needed to perform in that given environment. And of course, time is money, right? For a lot of us in the industry, especially those of you that are consultants and even customers alike, time is your one resource. It's your most precious resource that you have. Without time, nothing gets done. So time has to be allotted. Many of you probably even have time tracking systems that you log your time in each day. Say how long it took to do this activity, how long it took to do that activity. And that time eventually adds up, and that time costs money. And money is something that, at least in my opinion, I like to keep in my pocket more than I like to spend. My wife, she probably thinks a little bit of the opposite. All right, so when we talk about flexibility and we talk about HC spaces, we mentioned that we may have, a dance today, we may have a conference tomorrow. Think about a multi-tenant building, such as a large arena, indoor arena, right? Large indoors arenas could be anywhere from 5,000, 10,000 seats at some smaller colleges, all the way up to, say, something like Mercedes-Benz Stadium in Atlanta, right? You're probably seating 50, 60, 70,000 people. And the environment is used for multiple purposes, right? It's a football game on Sunday. It's a concert on Saturday night. It's a RV trade show or monster truck rally on Thursday night. You know, there's a number of different things that space evolves to over time. So let's look at an arena and how an arena kind of qualifies into a network of the future. All right, so we look at a kind of a sample drawing here of an arena. Picture, obviously, each of the blue dots would be an AP cell. So this would be our full AP deployment, right? But if we think about how that space evolves over time, how long do we actually expect every single AP in this configuration to be operational? How many use cases could you think of where not only would you need coverage on the floor area, which would be the middle of the diagram, but you also need full coverage and high capacity and high density usage around the bowl itself for fans and spectators that are watching an event? Not very often, right? Usually it's gonna be in that type of environment, it's gonna be an either or. You're gonna have a basketball game on the floor, you're gonna have a wrestling match, something of that nature, where the bowl would be highly used, but the floor itself wouldn't be. Well, as we know in wireless, right, the one thing that we always wanna make sure of is that we control the number of BSSIDs in the air. Because the fewer BSSIDs in the air, the more airtime that we have to devote to clients, the faster clients can get on and off of the medium, the more data that we can carry, the better performing network we have. All right, so what do we do? How do we make this a network of the future, right? We need it to be flexible. So as you can see here, we've got blue and red dots. Blue is on, red is off, all right? So when we have that basketball event, right, we're not concerned with the airtime from the APs in the middle of the floor. Now in this case, we've got, let's see, we've got 8 pictured here. In most of the indoor arenas that I've done of this nature from a deployment and design perspective, you're looking at probably about 12 APs, depending on height of mounting, what antenna beamwidth you're using, and things of that nature, kind of so on and so forth. But for the purpose of this drawing, we've got 8 APs. So in reality, those 8 APs may not make a huge difference, right, to how the network performs. But if we look at wireless, and we all know that based on some discussions that we heard yesterday, right, wireless is a math, it's a function of math. And one of those functions of math is time. And when we're talking about milliseconds used to transmit these packets across the air, right, a handful of milliseconds to you or I just went by like that. However, in that handful of milliseconds, how many frames were transmitted in the air from the people here, just here in this room, for instance, right? So we multiply that out to a larger venue that seats maybe 10,000, for instance, and you see how valuable those fractions of a second really become. So here our layout is for, let's say we have a concert on the floor or a sporting event, and our fans and spectators in the seats are observing it, posting to YouTube, posting to Snapchat. It's actually interesting these days, you know, growing up, I went to a sporting event to actually watch the sporting event. You know, nowadays, I think the topic has become more of a social event, if you will, where people are spending more time uploading pictures on all of the event than they are actually watching the event itself. I equate it to, I love photography, I equate it to the old adage of a photographer is sometimes you have to get out from behind the camera, right? Quit looking at life through a viewfinder and actually focus on the bigger picture, because you never know what you'll miss. But let's say the next night, we flip that to a trade show, right? Where we have multiple vendors on the floor now. We're processing credit card transactions for purchases, point of sale operations, things of that nature. No longer are those 100 APs around the bowl needed, right? They're just taking away unnecessary airtime, throwing all those beacons into the air. Why? I mean, there's something that we could do to kind of improve the network. So we have this set up now where we had a switch flip essentially overnight, where we turned off all of our bowl APs, we brought up the floor APs, and mind you, all this can happen dynamically in the background, right? We have things like RRM protocols and all from multitude of vendors now. I think every vendor has one that they utilize in different ways, but we can kind of flip that instantly. So let's expand that one step further. So let's think about a network of the future and how we can make all these things happen dynamically, right? How many of you kind of work with like convention centers or have customers that are convention centers or big venues and all like that are multi-purpose out there? Quite a few of you? Okay. So what if, for instance, we had a scheduling system set up? Many of you do, right? You have to track that time for those venues, make reservations and so on and so forth somehow. What if your secretary could be the network administrator. And many of you are sitting there going, well, there's just no way. I mean, my secretary may be the smartest person in the room. In some cases, I think they may know more than the executive staff because they handle the day-to-day operations. But network administrator, wireless administrator, I don't know. Maybe we could train her to do some low-level things, hey, look at this thing, see if the APs are on or off. But what if her efforts or his efforts sitting behind the desk, putting a reservation into a scheduling system, sets into motion a series of events on the back end where that trade show event now, with a simple checkbox of trade show, sends an API to our wireless controller at a specified time, flips that switch for us. It turns off those bowl APs. It brings up the house APs. We can set preset power levels. We can allow RM to kind of settle in overnight if need be. And the network administrator, you or I, gets to go sit back and, have a cold beer or glass of water on the weekend, enjoy some sweet tea on the patio, and, we're not worried about what the network does because it's already been handled, right? That's what a network of the future is to me. So we kind of flip it to one other scenario that I do a lot of work in, and that's warehouses. And how, again, can we have a network of the future perform in a warehouse? Same type strategy, right? We kind of expand here a little more because now we have a venue that's not changing its purpose, right, from day to day, hour by hour, minute by minute, right? This is a warehouse, 24/7, plain and simple. Amazon, whoever you want to think of, right? These operations are 24/7. They're very important. It's critical that the network performs well. So how do we make a warehouse network a network of the future? Okay, well, as you see on the left here, we've got a capacity gauge, right? So let's think about, for purposes of the time period that we're in, Christmas is coming up here pretty quickly. Many of the stores already have Christmas merchandise out on the floor. At a Christmas, this Christmas facility, for instance, may carry a larger level of inventory, right? So it now has more items on the shelves, requiring more signal in more places, to borrow a term from some of the sailor vendors out there, to get the network to perform as it needs to be, right? We're having to attenuate through more objects on the shelves, so we need more APs. But now, let's say Christmas ends, it's January, this warehouse is gonna kind of go somewhat dormant for the next 6 to 8 months, before the next holiday cycle starts. Well, now we have shelves that are at a much lower capacity. So why do we need all these APs, right? Why do we need to increase co-channel and adjacent channel interference in the space and consume airtime that's kind of unnecessary now when we can handle it with just a few APs, right? This is how a network of the future is flexible. It gives one network, but multiple ways to provide service depending on what time of year it is. All right, so we talk about cost efficient. How is the network cost efficient? So I have a slide here called Going Green, right? So I've done a little bit of math on the background, a little bit of research. So by my approximation, most average access points with no client association, just kind of beaconing out 1 or 2 BSSIDs per radio, is going to consume somewhere around 8 watts. That's give or take a few watts by the access point, kind of made up on the back end from the switch side and PoE perspective. But let's just say for the sake of the argument, we've got an AP consuming 8 watts. The average cost right now in the United States for electricity is roughly 13.02 cents per kilowatt hour. It's just a quick kind of Google search to come up with these numbers. So if we do the math on an access point that consumes 8 watts, again, let's just pretend for sake of the philosophical argument that we have no client associations. 8 watts of electricity, 24 hours per day at 13.02 cents per kilowatt hour, it's going to cost us about $9 US per year to operate that access point. Okay, so for the cost of a couple of lattes at your local Starbucks, you can run an AP for a year. But let's expand that out a bit. So in February of this year, just another quick Google search, Cisco crossed 2.5 million 11 AC Wave 2 units sold worldwide, 2.5 million. All right, so if we take that number of 2.5 million, we do the same math on it, it costs $22.5 million per year to operate those access points 24 hours a day, 7 days a week, 365 or 6 days a year. That's a huge investment. So we talked about a little bit about arenas earlier, right? So you look at stadiums like Mercedes-Benz, you look at the Giants facility, MetLife, you look at the Dallas Cowboys, behemoth in Texas, right? We're talking about thousands of APs, right? You're looking at potentially 12 to 1,500 access points per venue. These venues may only be used for, let's say, 8 days a month, right? So the cost savings alone in being able to have a flexible network that can power down these access points and save on electricity costs is enormous. If you had an access point consuming these characteristics for 8 days a month, let's say 10 hours a day for the life cycle of that event in the LPV arena, it's going to cost you $1 per year for access point, okay? So if you have 1,200 access points in a single stadium and you cut them from 24 hours a day to only 10 hours a day, 8 days a week, that's a savings of $10,000 a year, right? A lot of us would beg for that kind of money to be able to invest back into our system. So think about schools, right? Same principle. You're running classes from, say, 8 to 5, K-12s are, probably 8 to 4:30 maybe, depending on things a little bit earlier, a little bit later. Colleges may run a little later in the night. But, at 1, 2, 3 in the morning, those buildings are sitting there idle. Why do we want to continue to provide power and consume resources and spend money when we can use that money elsewhere to kind of improve the performance of our networks? So we talk about quality of life, right? That was one of our other considerations, is ease of administration or quality of life. So how can a network of the future improve your quality of life or become something that makes the ease of administration for a network perspective? Well, APIs. Again, we're not going to spend a lot of time here. Everybody knows what API stands for. If you don't, Application Programmable Interface. This is kind of where the future of wireless is going. Many of you have heard several discussions over the last 12 to 18 months talking about things like Python, right? Learning Python, how network administrators are becoming more programming people rather than just true administrators doing the day-to-day tasks that we do. The next way that we kind of improve quality of life via those APIs is artificial intelligence or machine learning. Now, I know that Bob's going to talk to us here in a little bit about Mist, talk about some AI things and all like that. From my point of view, I'll just be completely honest with you. I think artificial intelligence has kind of become one of those buzzwords, like, in the firewall industry, next generation used to be. I'm more of a machine learning person. I think machines take the information that they ingest, and via programming and logic that we as humans put behind those things from a programming perspective, is a better discussion and a better kind of presentation of what that actually is versus calling it artificial intelligence. I would all love to see, HAL actually become real life, but until then, I think we've got a little ways to go before we can call it true artificial intelligence. But these things are ways that we make our lives as a network administrator easier. All right, and finally, we talk about smarter networks, right? So what do I mean by smarter networks? We need networks that are able to anticipate network usage levels, right? We talked about that secretary scheduling events in the system and triggering all these back-end functions and all that are happening to dynamically change the network over. A network of the future is one that can anticipate those changes for us and automatically bring things up. Aruba did this with their team at Atmosphere. For those of you that went to Vegas this year, they actually had NetInsight and some other systems running in the background that selectively and programmatically changed the network on the fly because they saw that, levels in the dining area, for instance, right? When levels dropped off after breakfast, between breakfast and lunch or lunch and dinner, for instance, we didn't need, 50 access points broadcasting all these networks for high-density coverage, right? We just needed kind of the bare-bone minimum to provide coverage for those that may walk in and have the transient user, so they stay connected to the network or do a pretty low-level application, just little bits of data here and there. But it also knew that based on pattern recognition and learning from the machine learning side of the things, that, hey, it's 11 o'clock, we're going to start seeing more people come in, so let's go ahead and bring some of those access points back online. These are things that networks of the future need to do. They need to be constantly user and application aware, right? So we need to know that at a business, for instance, from 8 to 5, we're going to have a lot of Skype calls, right? So we need to automatically go into our configs, maybe change some QoS rules to allow better performance of that, and say after a 5 o'clock ride, you've got a lot of kind of people that, well, I just really don't want to go home, or for those that live in, Los Angeles, Atlanta, just don't really want to deal with traffic yet, so I'm going to kind of kill a few hours, but I'm not really going to work, right? So what are you doing? Maybe a little Netflix, maybe a little Pandora, something of those natures, right? Where QoS really isn't something that needs to be applied to the network at that point. So we've got these networks that are dynamically shifting their purpose and their functions throughout the day automatically without us having to interfere with them, and yet they still perform well. And finally, we need a self-healing network to be a network of the future. We need one that it knows what's going on with its access points. It can sense if there's degradation on a particular channel or a particular radio from a performance perspective. So, we have ARM algorithms and RM algorithms now that kind of sense that throughout the day and maybe shift to a different channel. But what happens when, an AP goes out or maybe we automatically lose backhaul? Those are the kind of things that networks of the future need to be able to do on a daily basis to truly be a network of the future. So we've talked about the 4 points of being a network of the future, right? We've talked about ease of administration. We've talked about cost efficiency. We've talked about, we talked about flexibility, and we've talked about smarter networks being intelligent. Well, guess what, folks? The future's here. We have a lot of these things. We have the capabilities already in place via APIs and things that are coming out shortly or are already out on the market to become a network of the future. It just takes you and I to sit there and make sure that these networks are performing and configuring properly so that they can be that dynamic network that we need today. And I have 15 seconds. Questions? Nope? Okay, good deal. Thanks, everybody.